Including open-ended questions in surveys is important but challenging. This textual data is difficult to analyse, so many of us researchers are far more confident dealing with closed questions, leaving responses from open-ended questions underutilised. This means that we miss out on learning from this informative data, which is less constrained and may contain novel answers we haven't previously considered. Our team have created an R package, Fin Survey Text, which supports researchers to conduct qualitative analysis on Finnish open-ended survey responses. The package includes functions that can be used to prepare and annotate text data into a standardized format, which is easier for analysis, to explore the data to find trends and topics, to compare responses between different groups of participants, and to visualize these findings. So let's see the Fin Survey Text package in action. Here we have a survey from 2012 of young people's views on development cooperation, which is from the Finnish Social Data Archive. This survey is included as sample data with the package. The survey contains some open-ended questions. Let's specifically look at this question, which asks respondents to name the 3 biggest current problems in the world. Here we have the raw data in a CSV file, which we have downloaded from the archive website. We can see the relevant question is in this column. Now we will prepare the data for analysis. The Fin Survey Text package includes a function which converts our data into a convenient format. In this format, we can see that the sentences have been split into individual words, which have been annotated with their relevant part of speech tag and lemmatized to a base form. Once the data is formatted, we're able to run some initial exploratory functions to begin to understand how our survey participants have responded to this question. From our results, we can see that the question was answered by 97% of survey participants, that most of the response words are nouns, adjectives, and verbs, and that most responses consist of a single sentence of a few words. Now we can take a closer look at these words by creating a word cloud, visualizing the frequency with which words occur. From our word cloud, it is clear that war, poverty, and famine are the 3 most frequent words, with other words like climate change, man, water, hunger, and inequality also being quite common. To better quantify word occurrence, we can create plots of the most common n-grams. An n-gram is a set of n words in order. Here we have a function which plots unigrams, so the most common words. In this table, we've asked for the 10 most frequently occurring words. As expected, the 3 most common words which we identified previously are at the top of this table. In the next plot, we're looking at bigrams, so sets of 2 words in order. We can see that water, a frequent word that we found previously, is commonly mentioned in phrases like clean water and lack of water. And in fact, the most common trigram is actually lack of clean water. Returning to our top 3 words, war, poverty, and famine, we can further visualize the use of these terms through a concept network. Our concept network function uses the text rank algorithm, which is a graph-based ranking model for text processing. In the network, vertices represent words, with the importance of words indicated by the size of the node. Co-occurrence between words is shown through edges, with more frequent co-occurrences shown as thicker edges. Word importance is determined recursively, where words get more weight based on how many words co-occur and the weight of these co-occurring words. We can see our concept words are shown here in red, and we can also see that the network shows the common use of phrases like lack of water and clean water. Now that we have a better understanding of the data as a whole, we might wonder whether different cohorts of survey participants have responded in different ways. Each of the analysis functions I have shown so far has a counterpart for use in comparing cohorts. Each of these functions can compare up to 4 groups of participants. For instance, let's see whether gender impacts word choice. In this analysis, we have excluded survey responses where the participant did not provide a gender, as this group was very small, and we have split the remainder of responses into female and male. By plotting word clouds separately for these two groups, we can see that famine seems to be mentioned comparatively more often by female participants, and conversely, climate change is more frequent in male responses. Next, we will produce n-gram plots for males and females. Here, we've asked for the 10 most common words used by males and females in their responses. Words that occur in only one of these top 10 lists are highlighted in red. This table, which is normalized by the number of respondents, shows us a few things. Firstly, while both genders have the same top 4 words, we see again that famine and climate change are more common responses by females and males respectively. Secondly, we note that nearly 30% of women mention their most frequent word, whereas for males, this number is closer to 20%. This could indicate that there is more variation in the response to this question by males. These two findings could prompt further research into whether, for instance, male respondents show more concern about climate change than females within other questions in the remainder of the survey. Now looking at bigrams, we can see that while both males and females frequently mention lack of water, clean water, which is the most common bigram by female respondents, is not frequently mentioned by males. Again, this could prompt further analysis into different levels of concern by male and female respondents. Finally, let's look at a concept network for the top 4 words by both male and female respondents: war, famine, climate change, and poverty. Interestingly, our concept network plots of these top 4 words show that there is a much larger variety of terms used by female respondents who mention these 4 common responses. Words unique to the female plot are coloured in green. Only part of this is explained by the fact that we have nearly 4 times as many responses from female participants, since each of these plots have their vertex weights determined only from their cohort's responses. Therefore, there may be other subgroups within the male respondents who discuss independent themes to these. The Fin survey text package can currently be accessed on GitHub, and we hope that it will be available via the CRAN shortly. All the functions within the Fin survey text package are customizable to your dataset, allowing you to really interrogate what your survey participants are telling you in their responses. We hope that the Fin survey text R package will provide researchers with a framework which allows them to feel more confident including open-ended questions within their research.